Okay, now let's look at how we can do some follow-up operations after filtering. So let's try to implement the relu function. So we have some array form np.array of 1 say minus 2 3 5 minus 6, and what you need to do is implement the relu function. So whenever x is greater than 0, so when I say x is greater than 0, when the element one of the elements in x, right? So when one of the elements in x or one of the components of x, when it is greater than 0, you have to retain that particular value of x, okay, or rather that particular component. Okay, when I say x, what I mean is that element, right? So let's say if the third element, in this case 3, so third element is greater than 0, so what you need to do is you need to retain that value. If it is negative, then you have to substitute it with 0. Okay, so this can be accomplished using a method called np.var. So let me run this and show you what happens. So 1 is greater than 0, so 1 was retained, minus 2 is less than 0, therefore it was substituted with the value 0. Okay, so notice that in this case the shape of this array will be the same as the shape of the input passed to it. So if you call this say z, then if you compare x dot shape, that should be the same as y dot, so as z dot shape. Okay, so this is a very useful function np dot var. You could use it for other purposes also. So now we come to this concept of view and copy. So let me start off with an example array and then show you what view and copy means. Okay, so let me say that this is np dot a range of 1 comma 6. Okay, this is x. Now what are we trying to do now? So we are trying to slice x. Let's say the first three elements of x, so that is 1 2 3. And what I'm going to do now is I'm going to change the 0th element of y and make it 10. So y now is 10 to 3, and I want to see if whatever I have done has had any effect on x. So I'll see what x has become now. So lo and behold, x has also changed, right? So the first element of x or the 0th element of x has also changed in this process. So what is happening? The underlying data. So the underlying data is shared between x and y. Okay, so y is called a view of x, right? So slices, whenever you have slices, they always create views. So you have to be very careful when you create a view in this process. So when you slice and you put that into a new variable y, y and x are going to share the underlying data. So any changes to y will also change x. Okay, so there's another example. So usually whenever it's possible, the reshape method will also create slices. So for example, let's take np.arange of 1 comma 6, okay, or say 1 comma 7. So this is x. Now let's reshape this as a 2 cross 3 matrix, right? So 2 cross 3. So that will, what will m be? M will be this 2 cross 3 matrix. And now let's, so what we'll do is we will change the first column, or rather the first row of the matrix. We'll turn it into, let's say, 10 11 12. Okay, so what have I done? I've changed the first row of the matrix in place. I've changed it to 10 11 12. So now m looks like this. So m was earlier 1 2 3 4 5 6. Now it's 10 11 12 4 5 6. Now let's go and see what has happened to x. Notice that x has also changed. Okay, so the first row of x corresponds, first row of m, or the 0th row of m corresponds to the first three elements of x. And you notice that when you have changed m, you have also changed x. So what does this mean? M is a view. Okay, so m and x share the underlying data. So whenever possible, reshape method will create a view. It will not copy the entire data, but it will create a view, meaning the base data will be shared. Okay, so that is regarding view. Let's say you don't want this to happen. Let's say you want to create an entirely different copy of the data in this process. So what do you do in such a situation? So let's see what can be done. So you have x equal to np.arange 1 comma 7, and you want to create, you want to reshape it to 2 comma 3. Okay, but you don't want it to share the data, so you want to create an entirely different copy. So now let's see what m is. So this is m, so this is x, this is m. Okay, so that much is clear. Now let me repeat the same process where m of the zeroth row I'm changing it as in place. It's an in place operation. So m now becomes 10, 11, 12, 4, 5, 6. But if you look at x, x remains 1, 2, 3, 4, 5, 6. So what we have done is in this process, we have created a copy using the dot copy, using the copy method. Therefore, m and x no longer share the base data. Okay, so they are two different. They have m has its own copy of the underlying data. Okay, so they are not the same. So that's the difference between view and copy. All right. So let's look at few other operations and see what they produce. Basic indexing by means of slicing always produces views. Okay, reshape whenever possible produces a view. Now advanced indexing always produces a copy. So what do I mean by that? Let me take once again, say let me take this array, say minus 1, 10, 2, minus 5, 6, minus 8. Okay, and let me do advanced indexing. Let me retain all the positive entries in x. So this is x, this is y. Okay, I have retained all the positive entries in x and I have put that into y. So is y now a view or a copy? So let's change one of the, let's say the zeroth element of y. Let me make it 100. Okay, if it is a view, then something in x should also change. Let's see if that happens. So this is y. What is x? Notice that x has not changed. So minus 1, 10, 2, minus 5, 6, minus 8. X remains the same. Only y has changed. So what this means is that advanced indexing, what we can observe here is that advanced indexing produces a copy and not a view. Okay, so there is a useful command to check if something is a view or a copy. So y is, in this case, the result of an advanced indexing operation, right? So if y dot base is none, then that means that if this is true, right? So y dot base will return something, and if this is none, okay, let me repeat that. So if y dot base is none, if this evaluates to true, then that means that you have a copy. If not, if this returns, so if this evaluates to false, if y dot base is none evaluates to false, then you have a view. Okay, let's see that. Let's see an example where it's a view. So let's take np dot a range of 1 comma 10, 1 comma 11, and let us reshape x as 2 comma 5. Okay, now this is x, this is y. So if y is a copy, then y dot base is none has to evaluate to true. Let's see what happens. It evaluates to false. Okay, so let's take a look at what y dot base is. So y clearly is a view in this case, right, and not a copy. So what is y dot base? It actually points to the underlying array, right? So y dot base is x. You see that this evaluates to true. Okay, the base array is x in this case, and y is a view of that particular. It's a view of, and from where does that view come? From x, right? So y dot base is x. This evaluates to true. Y dot base is none. This evaluates to false because y is not a copy. Okay, so that is regarding views and copies. Now let's look at some important operations that can be performed along a particular axis, right? So there are, let's take the case of in this matrix 2D array. So 1, 2, 3, 4, and 5, 6, 7, 8. Okay, what we want to do is we want to find the sum of the row vectors. What do we mean by the row vectors? So 1, 2, 3, 4 is one row vector, 5, 6, 7, 8 is another row vector. We want to sum these two. So what is happening is that we want to sum elements in the array, but only along a particular axis. In this case, along the axis 0. So easier way to remember this is top to bottom. Okay, so why do I call it top to bottom? Because axis equal to 0, the 0th axis is in charge of this movement from top to bottom, right? So for example, so a of 0 will be the first row, a of 1 will be the second row. So when you change the index along the axis 0, 0th axis, this is like a top to bottom movement. So I want the sum of elements in A, but along axis 0. Okay, so I'm So notice that that gives us the sum of the row vectors. Okay. Now a similar operation can be done for the sum of the column vectors. Okay, 1 comma 5 is the column, 2 comma 6 is another column vector. So how do you do that? So np dot array of, I'll first define a 1 2 3 4 5 6 7 8. Okay, so I want to sum the elements of a along axis equal to 1. Okay, so what is axis equal to 1? This is the second axis, or if you use zero indexing, this is axis 1. So as I keep changing the index in this axis, what do I get? I get different columns, right? So I'm in effect, the movement is from left to right. You can think of that visually as a movement from left to right. So if I sum along axis equal to 1, I'll get the sum of the column vectors. Okay, so these are very important operations in NumPy. So please take a moment to study them carefully. We look at a few more. So let's find the following quantities for this matrix. So you have the matrix here, which is what it's actually a range. I just use the shorthand now. So it's 1 to 10. So meaning this will be 1 to 9, and I'm reshaping it as a 3 cross 3 matrix, right? So what will this be? This will be the matrix that we have defined here, right, in mathematical notation. So we want the sum of the column vectors. So what is that? X is equal to 1. So that is the sum of the column vectors. We want the mean of the row vectors. This can be achieved using a method called mean, and we want the mean of the row vectors, right? So this is how you do it. So where would something like this be useful? If your data set is represented in the form n cross d, then the mean of the row vectors would be the mean of the data points. Okay, so in these cases you can clearly see why this operation is useful. Variance of column vectors, right? It's m dot var, you have a var method, and you want the column vector, so the axis is 1 left to right. Okay, this is the variance. So few more operations. You can stack arrays. Sometimes it might be useful to stack arrays one on top of the other or one to the left of the other. So let's look at top to bottom, where you have a, which is np dot a range 1 comma 5 reshaped as 2 comma 2. So a is actually 1 2 3 4, and b is what? Np dot a range of 5 to 9 reshaped as 2 comma 2. So b is 5 6 7 8. So what is a comma b? This is a comma b. What you need to do is stack them from top to bottom. So there is a method called, very powerful method called concatenate. Okay, you are, instead of concatenating lists, you are used to concatenating lists in Python. What we are doing is we are concatenating arrays. So you want to concatenate this tuple of arrays a comma b. Okay, along the axis 0, right? Because you are doing a top to bottom, right? So along the rows is what, or along axis equal to 0 is what you are concatenating. You're calling that C. So let's see if this happens. So this is what you get, right? So what is C dot shape now? It should be 4 cross 2. And what is C? This is what C is, right? As expected. All right. What about left to right? So we have the same A and B. A and B remain the same. So C equal to np dot concatenate. Now it's a left to right concatenation. So it's a tuple A comma B that you're concatenating. The tuple contains A and B as its two elements, and axis equal to 1. Okay, so now if you visualize C, it's concatenated along axis equal to 1 or along the columns. So notice that the order matters, right? So if you replace a comma b with b comma a, obviously you will get a different concatenation or a different ordering of the columns. Okay,